Here's a quick hint. I'm trying to use mesh analysis instead of nodal analysis on an op-amp. I've set up the equations, or the nodes, the meshes, 1, 2, and 3. Now it might help to see more what's going on is if we use this model, because it might seem odd that you're coming down this line twice. So I have Rn, and you can see this mesh, then I have another mesh, and then I have the third mesh. So when I write the KVL for mesh 1, V1 equals I1 R1 plus I negative Rn. But according to the ideal op-amp model, this equals 0, and so I times Rn equals 0, and so V1 equals I1 R1. Well, the variable we're looking for is I1, and we already have it in terms of the input. And so there is no need for a matrix or anything like that because there's no I2 component in here. There's no I3 component in there. So then you can just do a quick solve for I1. Now, for this mesh, the KVL is minus I negative times Rn, Rn, plus I2 times R2 minus V out. Rather than use this equation here, it's just V out. This again goes to 0, so I get I2 times R2 equal to minus V out. And over here, I have I2, and there's no other terms. There's no I1 or I3 terms, so again, I just have I2 right there. V out over R2. Then yes, just like an all mesh analysis, you seem to need a little bit of KVL to solve them. I1 equals I2. And you can finish, if you have I1 equaling I2, you can get the standard op-amp equation, and IRL is just V out over RL. And so it's easy because there's no other components in each one. IRL would be the third variable, but it's just V out over RL. And so I hate to use the phrase it should be easy. Sometimes going for something easier makes it harder. I hope this hint helps.